Here's something most AWS AI practitioner study guides won't tell you. AWS shipped Bedrock Knowledge Bases with GraphRAG and Neptune Analytics integration in late 2024. They added prompt caching shortly after. The AIP-C01 exam tests all of it. So if your study material is more than 6 months old, you're going to miss at least 2 of the next 10 questions, and I'm going to tell you exactly which ones. Question 5 is the most exposed one. It's about a Bedrock feature most courses haven't even mentioned yet. 10 real exam-style questions, all current. Let's see how ready you actually are. Let's go. Welcome to PrepMyCert. This is the AWS Certified AI Practitioner, AIP-C01. 10 questions covering everything Bedrock, every governance pattern, every cost lever AWS expects you to know. Let's go. Starting with cost. High-volume Bedrock app, repeated prompts. The exam loves this scenario. You run a high-volume Bedrock API where most requests share a long system prompt. Users complain about latency and the monthly bill keeps climbing. Which approach reduces both response time and cost? The answer is B. Enable Bedrock prompt caching for the shared system prompt and tighten user prompts to use fewer tokens. Prompt caching is the new cost lever AWS rolled out for repeated context. Cached tokens cost a fraction of fresh tokens, and you skip the re-encoding latency on every request. Combine that with shorter user prompts, and you cut both bill and time to first token. Increasing max_tokens raises output cost. The largest model is the most expensive, not the cheapest. Disabling CloudWatch saves a few dollars on logs, but does nothing for Bedrock spend, and you've blinded yourself to where the money's actually going. Compliance question. The model says the wrong thing once, and now legal is in your meetings. What actually enforces the rule? A financial services firm uses Bedrock to generate investment insights. Compliance discovered the model occasionally outputs stock recommendations without the required legal disclaimer. The team needs to most reliably enforce that any investment-related response carries the disclaimer. Which approach fits? The answer is D. Bedrock Guardrails with output validation. Prompt engineering tells the model what you want, but the model will eventually drift, especially on the 1,000th request. Human review queues don't scale, and they slow down the product. Post-processing Lambda is reactive. By the time it appends the disclaimer, the unsafe output already left the model. Guardrails sit in line. They match output text against rules, and they block the response before it ever reaches the user. That's the difference between a guideline and a guarantee. For compliance-sensitive workloads, only enforcement counts. Operational question. 2 model tears, A/B testing on prompts, and you're not allowed to redeploy code. The right AWS service answers all 3. An e-commerce app processes requests through Lambda behind API gateway and calls Bedrock. The team wants to dynamically route premium customers to a higher quality model and standard customers to a cheaper one, run A/B tests on prompts without redeploying code, and validate that temperature and max_tokens stay within safe ranges. Which solution requires the least operational overhead? The answer is a AWS app config with feature flags and JSON schema validation. App config is purpose-built for safe runtime configuration. JSON schema validation catches a bad temperature value before it ever rolls out. Feature flags let you A/B test prompt variants without touching code. And the app config agent caches the current configuration in your Lambda runtime, so every invocation reads it in microseconds. No extra Lambda call, no DynamoDB query. Elasticache adds a cluster you have to manage. DynamoDB on every request adds latency and cost per call. Parameter store with EventBridge redeploys violates the no redeploy requirement entirely. AppConfig is the AIP-C01 answer for runtime config of any Bedrock-powered system. Quality assurance. New prompt template. You want to gate it, you want metrics, you don't want a person doing it manually. What does AWS recommend? Your customer service team uses Bedrock to generate replies. Before any new prompt template ships, you want to automatically compare it against the current one across a fixed set of inquiries, get quantitative quality metrics back, and block deployment if quality drops. Which solution fits with the least custom code? The answer is B. Bedrock Model Evaluation Jobs gated through code pipeline. Model evaluation is the AWS native quality assurance service for generative AI. You upload your prompt dataset, it runs every variant through the model, and it returns structured metrics, factualness, relevance, toxicity, custom rubrics if you want them. Code pipeline reads the score and gates the deployment. Sample and comprehend on production traffic is risky and sentiment is not quality. Latency alarms tell you about uptime, not output quality. Manual review with humans does not scale and is not automated. Model evaluation is the answer the AIP-C01 exam expects when you see the words evaluate prompt quality or gate deployment on quality threshold. This is the one I promised. Multi-hop entity reasoning over financial data. Most courses don't even cover this yet, but the exam does. A financial analyst team builds a RG app over data with deeply interconnected entities. Funds hold stocks. Stocks belong to sectors. Sectors face specific regulators. Analysts ask multi-hop questions like, which sectors held by my fund face new regulations? Responses must arrive in under 3 seconds with the least operational overhead. Which solution fits? The answer is B. Bedrock Knowledge Bases with GraphRAG and Neptune Analytics. This is the feature most courses haven't caught up to yet. Vector similarity search alone cannot traverse explicit entity-to-entity relationships. If you ask a vector store, what's related to my fund, it returns documents that mention the fund. But walk from my fund to its holdings to those sectors to their regulators, that's a graph traversal, and it has to happen in the retrieval layer, not in your application code. GraphRAG with Neptune Analytics is AWS native answer. The graph engine traverses relationships in milliseconds. Lambda chaining vector queries is the slow workaround. Manual relationship code on EC2 is the operational overhead the question is explicitly trying to avoid. If you didn't know GraphRAG existed before this video, you would have picked C or D, and you would have been wrong. Security and compliance. PI in your RAG pipeline. 3 requirements. 1 option satisfies all 3. Your RAG workflow on Bedrock retrieves documents containing PI before forwarding context to the foundation model. Compliance requires that only the specific Lambda role can read the documents, every read is auditable, and storage at rest uses customer-managed keys. Which combination satisfies all 3 requirements? The answer is at least privilege IAM on the Lambda role, KMS encryption on the S3 bucket, and CloudTrail kept enabled. PI safety on Bedrock is 3 legs. IAM least privilege controls who can retrieve. KMS at rest defends against any storage level breach. CloudTrail captures every retrieval as an audit event. All 3 are required. Open cross-account access is the opposite of least privilege. Disabling CloudTrail eliminates auditability, which is non-negotiable for any PI workload. A shared IAM user across services and unencrypted DynamoDB storage fail every basic compliance review. The AIP-C01 exam expects you to recognize the full security stack, not just one piece of it. Hard 1. Natural language to SQL with Bedrock. Simple queries work, complex ones return garbage. Why? A company uses Bedrock to translate natural language questions into SQL queries against their sales database. Simple queries work, but complex ones, joins across tables, aggregations, return SQL that's syntactically valid but semantically wrong. The team wants the biggest accuracy gain without manually writing examples for every possible query. Which approach helps most? The answer is C. Bedrock Knowledge Base of the Schema, foreign keys, and example SQL, retrieved via RAG. The model doesn't know your schema. No amount of prompt engineering changes that instructions are not facts. Fine-tuning bakes the schema into the weights, but the moment a column changes, the model is wrong again, and you're paying for retraining cycles. Agent-based trial and error is slow, expensive, and risks running destructive queries against production. RAG is grounding. You retrieve the relevant schema and example queries per request and inject them as context. The model now generates SQL from actual facts, not guesses. RAG is the antidote to hallucinated SQL, and the AIP-C01 exam loves this exact pattern. Reliability. Your model's responses are inconsistent. How do you actually evaluate it? Your Bedrock-powered application returns inconsistent answers to similar prompts. Stakeholders ask how you'll evaluate and improve reliability. Which two-step approach actually works in practice? The answer is B. A/B test prompt variance for consistency, then measure outputs against a reference dataset for groundedness. Top P and temperature are sources of randomness. You can't fix randomness by tuning randomness. IAM policies don't influence model output consistency at all. That's a misdirection. Random model switching adds noise on top of noise. Reliability on generative models is two pieces. First, A/B test prompt variance and pick the one with the lowest variance in output. Second, take that variant and measure its outputs against a reference dataset to confirm the answers are factually correct. Consistent and correct, the exam wants you to see both legs. Big governance scenario. Financial services. 6 requirements. Pick the option with the least operational overhead. A financial firm is deploying a Bedrock app that gives investment advice. It must detect hallucinations, apply safety controls, monitor model drift, retain audit trails of every prompt response pair, integrate with the existing compliance dashboard, and respond within 200 milliseconds. Which solution meets all requirements with the least operational overhead? The answer is B. Bedrock Guardrails for safety, Bedrock Model Evaluation for hallucination detection, DynamoDB with TTL for audit trails, and CloudWatch custom metrics for the compliance dashboard. Every piece is a managed AWS service that integrates natively. SageMaker Model Monitor isn't built for generative AI hallucinations, and AWS WF doesn't filter LLM output text. Option A is the wrong tools. OpenSearch and QuickSight in Option C are heavy operational overhead for a problem Bedrock already solves. Option D pushes most of the work into custom Lambda code, which violates the least overhead requirement. The pattern AIP-C01 wants you to recognize is that Bedrock has guardrails, model evaluation, and CloudWatch integration built in. Your job is to know they exist and combine them. Last one. Hardest one. Routing rules across regulatory zones, hourly cost thresholds, no redeployment allowed, thousands of concurrent requests. What's the architecture? An e-commerce company runs a global Bedrock recommendation system. Routing rules must consider user tier, transaction value, regulatory zone, and an hourly cost threshold metric. Routing rules must propagate across thousands of concurrent requests within seconds, with NO code redeployment when rules change. Which solution fits? The answer is D. One Lambda fetches routing config from the app config agent on each request, evaluates the business logic and process, and forwards to the selected Bedrock model behind a single API gateway endpoint. Lambda environment variables require a redeployment to change that breaks the requirement immediately. API gateway transformation templates can express logic like, cost this hour less than threshold. TL doesn't do math like that. Lambda authorizers in front of separate lambdas per model multiply your cold starts and your cost. The clean answer is one Lambda, app config agent retrieving rules from in-process cache in microseconds, full programming language to evaluate complex business logic, and a single endpoint exposed to the world. Updates propagate the moment you publish them, no deploy required. This is the production-grade pattern for dynamic Bedrock routing, and it's exactly what the AIP-C01 exam tests when you see thousands of concurrent requests plus rules change frequently. That's all 10. How did you do? 8 or more, you're genuinely AIP-C01 ready, and you're up to date on Bedrock's modern feature set. 6 or 7, you've got the foundations, but you're behind on at least one major topic. 5 or below, that's exactly why you're watching this. Drop your score in the comments. I want to know whether the GraphRAG question caught you, and whether the app config pattern was new. If you want the full AIP-C01 experience, hundreds of questions like these, every Bedrock domain covered, every cost lever, every governance pattern, full-timed practice tests, head to PrepMyCert.com, lifetime access for one payment, and a full refund if you don't pass. Link in the description. Go pass that exam.